Okay, so good day. Today we're going to discuss about data storage in Android programming, to be specific, or in mobile programming. So data storage in mobile programming, of course, refers to the techniques and methods used to store, to manage, and to retrieve data on mobile devices. So given the constraint of mobile environments, including limited storage, capacity, intermittent connectivity, and security concerns, we as developers must choose appropriate storage mechanism to optimize performance and ensure data integrity. The selection of storage options depend on factors such as the type of data, no, the access speed requirements, and synchronization needs. No? One of the fundamental types of data storage in mobile application is the internal storage, where data is stored privately within the app's allocated space. No? Internal storage is very suitable for sensitive data as it is inaccessible to other application unless explicitly shared. No? However, its availability is limited by the device storage capacity, and improper usage can lead to performance issues, especially on low-end devices. Another common method is external storage, where data is saved on removable or non-removable SD cards. No, external storage is beneficial for storing large files such as multimedia content that do not require strict access restriction. However, data stored externally is more vulnerable to corruption or unauthorized access. Now, as other application and even users can modify or delete the files, developers often use encryption or permission-based access to enhance security in external storage. And to give us more details about the topic, let us all welcome our presenter. Go ahead.
Presentation is about data storage in Android. So what is data storage in Android? This is used to store application data in databases, files, or preferences in internal or removable storage. Used to add a data backup service to let users store and recover application and system data. Android provides several options for you to save persistent application data. The solution you need depends on your specific needs, such as whether the data should be private to your application or accessible to other applications and the user, and how much space your data requires. Android provides multiple ways to store data efficiently, depending on the app's needs. These options include shared preferences, internal and external storage, SQLite databases, and Firebase real-time database and Cloud Firestore. First is the shared preferences. The shared preferences class provides a general framework that allows you to save and retrieve persistent key-value pairs of primitive data type. Typical usage of shared preferences is for saving applications such as username and password, auto-login flag, and remember user flag, and etc.
The next point is how to access data from shared preference. Means how to perform reading and write operation by using shared preference. So first we will see how to store the data. Suppose you are creating the object of edit text. Suppose you have two edit text in your program, one for saving username and one for password. So in that case you have to create share preference object. Get share preference. Here password data is nothing but your file name, and 0, that is nothing but your mode name. There are various mode, one by one we will see later on. Then by using this statement sharePreference.editor, you can edit the data. Then editor.putString means you can store the data in the mention file password data. So here name and password, these are the key, and their values are user.getText.toString. Means user whatever the value will enter, that will be stored in your app. So that is nothing but user.getText.toString. Then password.getText.toString means whatever the value user will enter in the edit text, that will be stored. Okay, so that will become your value. And here the key name is name and password. For giving the file name, you can use these two methods. Get preference, it is particularly used if you have one file. Get share preference, it is used if you have many file and it is having mode parameter. So mode values are like that. Mode private, it is default value, only app can access your data. Here second value means world readable, all app can read data, then all app can write data if you use third value. Fourth is multiple process can use the file. Generally we use the first default value. In place of writing mode private, you can write 0 also. Then next one is load method. So load means nothing but this method is used for reading value. As usual, you have to create the object of share preference. Then you use string variable name and password. And here you use getString method for reading the value. Then here name and password, these are nothing but the key and D is value. Here suppose in this example D value is null. Then what happen here in if statement? If the name and password value is null, then no data is found. Otherwise data is loaded, and for loading data you have to use u.setText, p.setText and name and password. So it means whatever the name and password will be there, that will be added in your edit text, that will be added in your text to component, and you can read the name and password. Next one is to clear all data. Then as usual you create again share preference object, use editor for editing, and then clear method, it will clear entire data. Finally use commit method. Then clear specific data. For clearing specific data you have to use remove method. It will clear the particular value. If you want to remove all data, you use clear method, otherwise you use remove. And at last you use commit statement. Whether you are performing reading or writing operation, don't forget to use commit method. Otherwise whatever the changes will be there, that will be not permanent. Then in this presentation here I am just giving the introduction of example. Then in the next tutorial we will do the programming for that. Here we have 3 buttons as I already told you. If you click on save, whatever username password there, it will be stored. If you click on check, next page will be loaded. And if you click on here load, username password will be available to you. If you click on previous, you can go back to first page. If you click on clear, it will clear all the data. So in this way it will work, and for doing this operation you have to use share preference. So then in the next tutorial we will do the programming for solving this task. So don't forget to see my next tutorial. Thank you.
Second one is internal storage. Android can save files directly to the device internal storage. These files are private to the application and will be removed if you uninstall the application. We can create a file using OpenFileOutput with parameter as file name and the operating mode. So let's watch the next video on how to use internal storage.
User can read and write the file whenever user want. Okay, and as you have seen in the share preference, user can also read and write the file, but the thing is that in the share preference we can store only primitive data like integer, float, boolean. But in internal storage there is no limitation. You can store any kind of information, and you can store more information in the internal storage. So that is the main difference between share preference and internal storage. And in internal storage the data will be removed once you uninstall the app. Okay, so now we will see reading and writing file in internal storage. So for performing the operation, first you perform write operation, because once you write the information then you can read. For performing writing operation there is a use of method, and this method is known as OpenFileOutput. By using this method you can create and save file. So this you can do this like that: file output stream, and this is the object, then OpenFileOutput, this is the name of the file, and this is the mode, that is private mode, default value. Here the value is 0. 0 means private mode. So by using this method OpenFileOutput you can create and save the file. For doing this you have to use the class fileOutputStream. So this class is used for doing writing operation. Okay, if you know Java you are already familiar. Then after this step you have to use write method. Write method is used for adding actual data in the file. For that you have to write statement like file output stream object, that is out.write method a.getByte and then next line b.getByte. So here a and b is nothing but the statement like user.getText.toString, means before this two statement you have to write a equal to user.getText.toString, then b equal to password.getText.toString, means you can access the value by using this statement, where user ID and password is nothing but objects of edit text component. Okay, means if you want to read the value from edit text, then you have to use this write method. Means what happening actually in this program, the user will enter the value in the edit text, and by using this edit text we are storing the value. So for that you have to use write method. Then after writing, you may perform read operation. For that you have to use open file input method. It is used to open file and read it. For that you have to use the statement like that: file input string object file input, then name of the file. Here you have to specify only name of file. Then after that you have to use read method for reading one character at a time from the file and then print it. Means you can read only one character at a time. For that you have to do the code like that. You can declare one variable with initial null value, that is -1, and suppose user is entering here Suraj and Datir. Okay, suppose our username is Suraj and password is Datir, means in the file Suraj Datir information is stored, and then our task is we have to read this information. So what happened, first you have to create a string buffer object. Okay, because by using string buffer you can easily access value and you can change value also. So by using string buffer you can perform the reading operation. So for that you have to use while statement. So meaning of this statement means it will check whether the data is present in the file or not. If the data is present, that value will be stored in the buffer. So for that we are using statement buffer.append, means one by one the character will be added in the buffer variable. For example, first yes is there, so it is not null, so it will be stored in buffer variable. Second is u, so in this way last one is r. After r there is a null value, null means -1, so loop will stop, because here the statement is value equals to find.read not equals to -1, means whenever it is not equals to -1 means whenever the value is not null, then it will append. So in this way it will read Suraj Datir. Then for reading these two strings Suraj and Datir, we are using separate statement, two variable a and b, then buffer.substring. Substring method is used to extract the string. Then 0. So here it is having actually two parameter. First represents start value, second end. So here the start 0 means I need to access the value from first position, so that's why it is 0. Buffer.index of here the space is there, means I want to read value up to space, so that's why I have given this statement. So index of means it return the position, it return the particular value from position. So by using this statement it will store Suraj value. Then for taking second value you have to use buffer.index of here space +1, means after space next character will be read, that is d, means we want to read a data from d, okay, up to null. So here there is no need to specify end value, so it will read Datir. So in this way next statement is u.setText, p.setText, a and b. Here u and p is nothing but the objects of TextView component, because we are storing data in the TextView. Then finally whenever you click on load button, whatever the data is there in the file in the form of user ID and password, that will be shown to you. Here if you click on previous, means you will ultimately go in the first page of your app. Okay, so that coding we will see in the next tutorial when we will program. Then in the next tutorial we will see the program which is based on internal storage example. As I already told you, user will enter user ID password, click on save, data will be stored in the file, and if the user click on check, new page will open, user can click on load, data will be read from file that you stored, and user can click on previous for going into the first page. So in this way this program will work out. Okay, so in the next tutorial we will do the programming for this So we will see in the next tutorial, we will see the internal storage example. And once again I tell you, this entire tutorial is divided into 3 parts. So this is nothing but the part 1, and don't forget to see all the part, that is part 2 and 3. Okay, so in the part 2 we are going to perform first writing operation, then in the part 3 we will perform read operation. So if you are new in this channel, don't forget to subscribe my channel. Thank you.
Next one is external storage. Every Android compatible device supports a shared external storage that you can use to save files. This can be a removable storage media such as SD card or an internal non-removable storage. Files saved to the external storage are world readable and can be modified by the user when they enable USB mass storage to transfer files on a computer. Before you do any work with the external storage, you should always call Get External Storage State to check the state of the media.
Directory. Then important step for the write operation is use as usual file class for storing data in the public folder. Then the location will be like this: storage, SD card, download. Means ultimately your data will be stored in SD card. So in SD card there is a download folder, or you can use video folder or other folder according to your requirement. Then you use same bunch of code except the method is different. Environment.getExternal storage public directory, and here you write directory download, means data will be stored in download folder. Then file name is user3.txt. Again same bunch of code is required for writing operation. Private storage. Private storage means first you use file class for creating private folder, and data will be stored inside the private folder. Data cannot be used by other app because it is private, and you use the method getExternalFileDir. Then step for external private storage are: first as usual you use file class, then your data will be stored in the storage. Here by mistake, here the spelling mistake is there, as you observe here. Storage, SD card, Android, data, package name and file. Inside the file your private folder will be created, and inside that you can save the file, and your file is user4.txt. Again you use same bunch of code. And then for reading operation we need separate class. For this class you can again use file. Again you have to follow same process. File is user1.text. This reading operation is nothing but for internal cache. If the data is null, then user.setText data, else no data is found. Okay, if data is not null, data will set, otherwise no data found. Then for reading operation use file input stream, and here this bunch of code we have seen in previous tutorial. By using stream buffer object, data will be stored in the buffer if the data is not null. Then same way you have to perform for external cache, external public and external private. Only the method will be different in the file class. Here for external cache, get external cache dir. Then for third external public there is a use of get external storage public, and for the fourth one get external file dir. Now you will find out this all code is little bit complicated, but don't be worried, it's very easy. Once we switch on Android Studio you will easily understand. Then in the next tutorial we will do the programming for reading and writing operation for storing data externally and internal cache. So don't forget to see the next tutorial for your better understanding. Thank you.
Next one is database. Android provides full support for SQLite databases. SQLite is a software library that implements a self-contained, serverless, zero configuration, transactional SQL database engine. Any databases you create will be accessible to any class in the application, but not outside the application. The recommended method to create a new SQLite database is to create a subclass of SQLite OpenHelper and override the onCreate method, in which you can execute a SQLite command to create tables in the database.
Next is SQLite database step. So in that first step is define constant for the table. Suppose you are creating table like that, which is having 3 columns. So ultimately you must have total 5 constant, one for database, second for table, and then remaining 3 for the column. Like we use here column 1, column 2 and column 3. So first one here it represents roll number, then name and hobby. So in this way you have to use the constant. And then next step is define query for creating database. So for that you have to use onCreate method. Then here you use execute SQL method and you write the command like create table, table name. And then you have to pass data type also. So for roll number we need integer data type because it will store integer number like 1, 2, 3 like that. And it is our primary key, means we want each value should be unique. So you can treat as a primary key and auto increment. Then next one is name, means it store the character, so it is character text data type. Then third one is also text data type. So in this way you have to use onCreate method for creating table. Then next one is onUpgrade method. So it is used to open and upgrade or change your database. So for that again you have to use execute SQL method and you pass the command like drop table if exists plus table name. So it will help you to open your database. It will help you to open your table. So then you have to use onCreate method. So by using this coding, your database, your table will open. And then remaining steps are nothing but insert data in database, show data, update data and remove data. And if I tell each and everything right now in this presentation, then what happened? You will have a lot of confusion. So in the coming tutorial, we will see how to create database, how to create table. Then we will see how to insert data, how to view, how to update and how to remove the data from database. So all these things we will discuss in coming tutorial. So I hope friend you enjoyed this tutorial and don't forget to see the coming tutorial which is based on SQLite database. Thank you.
Firebase Real-Time Database. The Firebase Real-Time Database is a cloud-hosted database. Data is stored as JSON and synchronized in real time to every connected client. Most databases require you to make HTTP calls to get and sync your data. When you connect your app to Firebase, you're not connecting through normal HTTP. You're connecting through a WebSocket. WebSockets are much faster than HTTP. And the last one, Cloud Firestore. The Cloud Firestore is a flexible, scalable database for mobile, web, and server development from Firebase and Google Cloud. Like Firebase Real-Time Database, it keeps your data in sync across client apps through real-time listeners and offers offline support for mobile and web, so you can build responsive apps that work regardless of network, latency, or internet connectivity. Cloud Firestore also offers seamless integration with other Firebase and Google Cloud products, including Cloud Functions.
Are you done?
Private. First, we'll use OkHttp. It's a popular open source library to create and execute our HTTPS request. We'll create our client, and now we'll get to the response. Once we get the response back, we double check that it has a response body. We rely on the .use method from the Kotlin standard library to close the underlying network socket automatically at the end of the lambdas to avoid any memory leaks. Finally, we save the request body into a file. As the file content is private, we'll save it into our app's internal storage using the context.filesdir property. To streamline our memory usage, we'll copy the request body content into our file by using streams instead of holding it entirely in memory. The Kotlin standard library has the .copyTo extension function to input stream instances to facilitate the copy towards output streams. Now, let's imagine that we need to download some large assets in our app that aren't confidential but are meaningful only to our app. So we would like to avoid polluting the shared storage with it. We would follow the same instruction as we did in our previous example, saving the big file to the internal storage as is the most available and performant storage location. Some devices may have limited space available on the primary volume, so we should check first if there is still some enough space there. If there is not enough space, we use the app's external storage directory. We should rely on the .get external filesdir method, as the device may have extra volumes like a microSD card. Finally, if there's still not usable space, let's show a notice to the user explaining the situation. Now, our app needs to add files to the shared storage, so the user can access them through other apps. If we want to add an image, we need to request the right external storage permission up to Android 9. On more recent devices, we don't need this permission anymore to contribute files into the shared storage, thanks to scope storage changes introduced in Android 10. For images, we will choose the Pictures folder returned by the environment.getExternalStoragePublic directory method using the environment directory pictures constant. If we're adding a video, we will choose the movies constant folder. If it's a PDF file, we will choose the download folder, etc. Now that we've copied the image into a new file, we need to scan the file using Media Scanner by providing its path and its MIME type. It will index the file metadata inside MediaStore, making it visible when apps query this content provider. For the best performance and access to more features like favorite, trashed, and pending files on Android 10 and above, we recommend using the MediaStore API to add files on the shared storage instead of relying on the File API. Check out our documentation for more details. Now let's go to another use case. Let's say we need to access document files, so we will rely on the document picker via the action open document intent. First, let's add the Jetpack activity dependency to our project if it's not there already. After that, we register our open document activity result, which will handle the intent result logic. If the user has selected a file, we'll have a URI that we can open using the content resolver. Finally, we launch our intent handler with the MIME types we want to filter on, and in this case, it's a PDF. The action open document intent is available on devices running Android 4.4 and higher. To access photos and videos on the shared storage on version up to Android 12L, you had to request read external storage and implement your own UI for the user to select the different items. But wouldn't it be better to just use something simpler for developers and privacy-friendly for users? Say no more. In Android 13, we introduced the Photo Picker, a privacy-forward way to select for images and video. It doesn't require any runtime permission and has a better UX to access photos and videos. It's maintenance-free, and you can even limit the number of selectable items. You can integrate it in your code in just a few lines of code, and it's backported to Android 11 and 12. In the upcoming months, cloud media providers like Google Photos will also be supported. The Photo Picker will seamlessly include backed up photos and videos to the selection grid, even if they are not saved on your device. Users will even see their custom and shared albums in the Albums tab. To use it, let's add the Jetpack activity dependency version 1.6 and higher to our project if it's not there already. After that, we register our Pick Visual Media activity result, which will handle the intent result logic. It will use the Photo Picker when available on the device and fall back to Document Picker for older devices. If the user has selected a file, we'll have a URI that we can open using the Content Resolver. Finally, we launch our intent handler with a filter: image and video, image only, video only, or specific MIME type we want to filter on. And that's it. 3 lines of code to select an image or video without permissions. If you want to keep access to a file even after your app is closed, you can call the take persistable URI permission to be able to keep access to them even after reboot. Your app may have a use case requiring this broad access like gallery photo backup. For these specific usages, we've introduced new permissions in Android 13 when targeting API 33 that provide access to specific types of media files, including images, video, or audio. You can read more about them in the documentations. Privacy and transparency have been tremendously improved over the recent releases of Android, with even UX enhancements like the photo picker. We're working on adding more APIs that keep the user in control of giving access while removing the need to request permissions on app sites. And lastly, as a recommendation for apps, rather than relying on file paths, which only offer access to local files and can be changed over different versions of Android, we're recommending to use URI to access files on Android. Have a look at our documentation for more details on the features I've presented today. Thank you.
Okay. Again, as our presentation, video presentation, we look into the shared preferences, because we just not only focus with Android programming, because there are certain cases that we have a cross-platform, So when it comes to shared preferences, it provides a lightweight mechanism for storing key value pairs persistently. So this approach is useful for saving small amounts of simple data, such as user setting, preferences, and authentication tokens. Shared preferences are typically stored as XML files in an internal storage, making them easy to manage. Easy them to manage. However, they are not suitable for a strong, complex or large amounts of data, such as structured records or the multimedia content, as I mentioned earlier. For handling structured data efficiently, the mobile application often use databases such as SQLite or Room for Android and Core Data for iOS. So again, Room for Android, Core Data for iOS, or SQLite. Databases enable complex querying, indexing, and efficient storage of large data. So it means to say, pag sinabi natin SQLite, for Room, Android, for Core Data, for iOS. They are ideal for applications that require offline access to structured information, such as contact lists, chat messages, or financial transactions. So while databases provide robustness and flexibility, they are also careful management to prevent performance bottlenecks and ensure data consistency. So cloud storage is increasingly becoming a preferred choice for mobile applications. So talaga ngayon, pag dito cloud na ba yan? And so on. Especially those requiring cross-device synchronization. Because cloud-based storage solutions such as Firebase, real-time database, Google Drive, or iCloud allowed users to store and access data remotely, reducing the dependency on a local storage. And this approach enhances data availability and security as cloud providers offer backup and encryption mechanism. However, reliance on cloud storage introduces concerns related to network latency, data privacy, and internet dependency. Another important data storage method is mobile development. In mobile development is the cache storage, which temporarily stores frequently accessed data to improve app performance and reducing loading time. So cache storage is commonly used in web-based application and multimedia apps to store images. API, no API responses and other frequently used resources. No, while caching improves speed, excessive cache usage can consume significant storage spaces or space and may require periodic clearing, no, to maintain optimal performance. So ultimately, again, students, selecting the right data storage method in mobile programming depends on the app's requirements, security considerations, and performance constraints. So developers often combine multiple storage mechanisms to balance efficiency, security, and user experience. So understanding the strengths and limitation of each approach helps in building scalable and responsive mobile applications. Okay, so I think that's it for this topic.